So in this problem, we are given 4 Cartesian coordinates and we need to find out their corresponding polar coordinates. So let us begin. So first, we'll consider the point 2, 2 times square root of 3. So let's go to our Cartesian plane. Now since the x and the y coordinate, both of them are positive, we are going to lie in the first quadrant. So let us suppose that this is the point 2, 2 times square root of, which is lying on the first quadrant, and let's call this point as P1. So what we'll do, our goal will be to convert this Cartesian point or the Cartesian coordinate into its corresponding polar coordinate. For that, what we'll do, we'll first join the point OP1. The OP1 is going to represent the radius, and here we can easily use the distance formula because the origin has the coordinates 0, 0. Using the distance formula, so I hope you're familiar with it. So we'll take the square root, and underneath the square root, first we will take the square of the difference of the x coordinate. So that's 2 minus 0 whole squared, added to the square of the difference of the y coordinate. So we have 2 times square root of 3 minus 0 whole squared, and this will correspond to a value 4. Fine. Now our next task will be to find out the angle theta. So here we'll have to be a little bit careful. So first what we'll do, from point P1 we're going to drop a perpendicular on the x-axis and call it A. So this gives us a right angle triangle OAP1, which is right angled at A. So here we will consider the y coordinate, which corresponds to 2 times square root of 3, and then we'll need the x coordinate value, so that's simply 2. So we'll try to find out this angle theta. This angle theta corresponds to the polar angle. So here tangent of theta, that's simply the y coordinate, which is 2 times square root of 3 divided by 2. So this is going to be equals to square root of 3. Now we know that square root of 3, that's a value that corresponds to a tangent of 60 degrees or pi over 3 radians. And clearly from this diagram, our theta value, that must be an acute angle. So pi over 3 makes perfect sense. We will consider theta to be equals to pi over 3. So hence, we have successfully converted our original point P1, which is 2, 2 times square root of 3, to its polar equivalent. So that will be the radius r, the angle theta, so that's pi over 3 radians. Now let's now go to the second part, which is 2 times negative 2 square root of 3. So here the Cartesian point or the Cartesian coordinate has a positive x coordinate and it has a negative y coordinate. Since its x coordinate is positive, so we are going to lie on the positive x-axis, and y is negative, so we have to go downwards. So this is going to correspond to the point 2, negative 2 times square root of 3, and I'm going to call this point as P2. Now our task will be to convert P2 into its corresponding polar coordinate. For that, let's join OP2. Fine. So here OP2 is going to be the radius. So the radius r is going to be, we can use the distance formula. So that's going to give us 2 squared plus negative 2 times square root of 3 whole squared. So here I have dropped the value for the coordinate of the origin because that's 0, 0. So this will correspond to a value 4. Now comes the task of finding out the angle theta. So we need to be careful here. So from P2, first we're going to drop a perpendicular on the x-axis and I'm going to name it, let's say, A. Now we get a right angle triangle OAP2, which is right angled at A. Now here we're going to first find out this angle. We'll come to the sign later. So to find out the angle theta, so first we'll take tangent of theta. So that will correspond to the y coordinate. The y coordinate is 2 times square root of 3. So here we're only taking the magnitude. So let's take the modulus of negative 2 times square root of 3 divided by the modulus of the x coordinate. So this is correspond to value square root of 3, and likewise we can find out the value of square root of 3. So that's going to be tangent of pi over 3. So here we cannot equate this to equation to get theta equals to pi over 3. So let's do that. So we'll get theta equals to pi over 3 radians. So this is an acute angle, and clearly from the diagram, this angle is angle theta. So this is going to be pi over 3. But here we have to be a little bit careful. We're going along the negative direction. That means we're going in the clockwise fashion. Now whenever we go in the clockwise fashion, then theta is measured in negative value. So we have negative pi over 3, and it's not going to be a positive value. So theta corresponds to negative pi over 3. So hence we have converted the point P2, which was in the Cartesian coordinate at 2 comma negative 2 times square root of 3, and its polar equivalent is going to be the radius 4 comma negative pi over 3 radians. Let's go to the third part. So here we have negative 2 comma 2 times square root of 3. We are going to lie in the second quadrant, because here in the second quadrant the x coordinate is going to be negative. We are lying on the negative x-axis, and the y coordinate is going to be positive, as we are in the positive y direction. Fine. So our task will be to convert the point P3 into its polar equivalent. First, what we'll do, we'll drop a perpendicular from point P3 on the x-axis and name it A. This gives us a right angle triangle OAP3, right angled at A. So it has got a y coordinate of 2 times square root of 3, and then we're going to only consider the magnitude value. So this is going to be 2 units. So let's first find out the radius r. The radius r, which is simply the point OP3, so that becomes equals to, so we have negative 2 squared plus 2 times square root of 3 whole squared, so that will be equals to 4. Then coming to the angle theta, so we have angle theta. Here we are trying to compute this particular angle, this acute angle theta. So let's call it, I'm going to call it phi here. So tangent of phi, this value is going to be equals to the y coordinate 2 times square root of 3 divided by the x coordinate. So this corresponds to square root of 3. So tangent of phi must be equals to, we have tangent of pi over 3. So phi angle is pi over 3. Fine. But we do not need this angle phi. What we need is the angle theta. So this corresponds to angle theta when it's measured from the positive direction of x-axis. So here it's very easy. So if we take this angle as pi radians, and from here if we subtract phi from it, this is simply going to give us the angle theta. So that means to find out the angle theta, all you have to do is take pi and from it subtract pi over 3. So this is going to be 2 pi over 3 radian. So we have successfully found out the angle theta as well. So finally P3 in its Cartesian form, which is negative 2 comma 2 times square root of 3, this corresponds to the value in its polar equivalent as 4 comma 2 pi over 3 radians. Now let's do the final problem. So in the part 4, we have the Cartesian coordinate negative 2 comma negative 2 times square root of 3. So this corresponds to a point that lies in the third quadrant, because in the third quadrant both the x and the y coordinates are going to be negative. So this is depicted in the graph here. So here first we will try to find out the value OP4. So OP4 corresponds to r. So our r value is going to be simply square root of negative 2 whole squared plus negative 2 times square root of 3 whole square. This is going to be equals to 4 units. Now to find out the angle theta, we will first drop a perpendicular from point P4 on the x-axis. This is the trick that we will use. We drop a perpendicular from point P4 on the x-axis and going to name it P4A, such that this triangle OAP4 is a right angle triangle which is right angled at A. Now we can find out the x component. We are going to only consider the magnitude value, that's 2 units, and the y component is 2 times square root of 3. And in doing so, we can find out this particular angle theta. Fine. So let's call it, we will find out this angle phi. So we'll first find out tangent of angle phi. So tangent of angle phi, so that's 2 times square root of 3 over 2. We are only considering the magnitude value. So this corresponds to phi equals to pi over 3 radians. But what we need here is the angle theta. So this is the angle theta and this is in the clockwise fashion. To find out angle theta, first all we have to do is take the angle pi. From it we are going to subtract phi. Now since we are going in the negative direction, so we'll have to consider the negative value of theta. So that means we finally have negative of pi minus pi over 3. So this is going to be equals to negative of 2 pi over 3. Okay, so this is one way. And if we want the angle value in positive So we can consider this particular angle. So starting from the positive direction of x-axis, we can consider this particular angle. Now that's fine. So because we know that from here up till here into the second quadrant we have pi, and then we have to grow an extra amount of phi. So theta could be also equals to pi plus phi. And we'll only consider positive values since we're going in the anti-clockwise fashion. So we're pi plus pi over 3. So this gives us 4 pi over 3. That means finally our point P4, which is given by -2 comma -2 times square root of 3. So this can have the polar equivalent of 4 units. So the radius value is 4 units and an angle of 4 pi over 3 radians. Or it could be P4 corresponding to 4 comma -2 pi over 3 radians.